Hi folks, this is homework number 5, uh, problem number 1, uh, and the problem that you're asked to do is a folded sheet metal like this. The dimensions are given here. You're told that the thickness of this thing is 2 millimeters, and it's made out of steel. Now the bottom edges here are clamped and the top circular edge is somehow pushed down by 1 millimeter. You're asked to use as many planes of symmetry as necessary. And in this case, of course, there's going to be two planes of symmetry, one cutting it like that, and the other one cutting it in this direction. So you have two choices. You can make the model as it is, and then uh, cut it into four pieces basically, or you can make the 1/4 of the model, whichever you want. So I'm going to actually create that model and then eventually split it two ways. Okay. The other thing you should keep in mind is that uh, there are different ways of doing this problem. The strategy that I'm going to follow does not require creating a solid object and uh, extracting the faces. This is what I gave as a possibility if you want to go that route, but I'm not going to do it like that. I'm going to create this thing as a surface directly. And again, to do that, there are many different ways of doing it. One way is to create this profile that you see here and then extrude it in a given direction. All right, so let's go ahead and do that. I'm going to start with the part file, and immediately I'm going to save it in a folder which is saying homework 5 problem 1. So file, save management, save as. On my desktop, I created a problem called, let's see now, maybe, let me see for a second. So let me go here. Oh, actually, sorry, let me go to desktop. I think it's in the do not delete folder. Do not delete videos. And this is homework number 5, problem number 1. And it's going to go there. Good. So on this vertical plane, I will sketch the profile that I just showed you. I'm gonna draw something and then clean it up like that, like so. There we are. I'm going to make it symmetric, so the left line control the right line, control the middle axis. We're going to make it symmetric. And once you do that, because very careful making sure that these things are tangent, etc., that's all we need. Notice that you can move this thing. Oops, control Z. Oops. Okay, so let me see now. I can make this, control that, control the middle axis, also symmetric. Okay, let's see if it's working now. Yep, you can see that. Very good. Let's dimension these things. So the distance from here to here is 140 millimeter. So I'm going to change this in 140 mm. Okay, which is roughly 5 inches, 5.5 inches. And this radius is 20 millimeters. All right. And that's pretty much it. Oh, this height. I forgot the height. I remember what the height was, 30 millimeters. Okay, so this, you see for a second? Yeah, this height is 30 millimeters. 30 mm. Good, exit. Let's check this thing, make sure it was actually 30 millimeters. 30 mm. Yeah, I guess it was. All right, so we're going to extrude that. And I'm going to use I'm going to use in both directions. Oh, I'm sorry. Cancel that. I completely forgot that I'm going to create a surface, so it cannot be in part design. So you're going to have to go to, for example, generative shape design. Yeah, so we have a profile there, and we're going to extrude this right there. Okay, in both direction. In each direction being 50 millimeters, which means a total of 100 millimeters. Now, on that face, I will sketch a circle of radius. I think the radius of that circle was 10 millimeters. So let's dimension this. 10 mm. That's right. 10. Oh, this diameter, so radius 10 mm. Good. Exit. Now I'm going to get the saw here. See that split right there, right next to joint? I don't have to join anything because of the way I did it when you extract it. When you extrude it, actually, when you extrude it, it's all going to be one surface. So when I put a thickness on it, the whole thing is going to take it. When I mesh it, the whole thing is going to get meshed, etc. So I'm going to split this. Read this thing carefully. It says element to cut sketch 2. That's wrong. That's because it was highlighted. See that? It's picked. Don't do it. Click left click so it's not highlighted. Then split. Element to cut is that surface. Cutting element is that circle. And then I'm going to cut it the other two directions. So split. Once again, cutting element is the surface, a vertical plane, and it doesn't matter which side you keep. And then again, split. This is the element to cut. Cutting element is this vertical surface, and there we are. So this is what we have. And let's apply some material on it, metal. Let's make it out of steel on that surface. Okay, and let's save everything. Now we're going to go switch to a generative structure analysis because I don't want to do a fancy mesh here. This is just a regular three-noded triangular element will do the job. Now notice that because I have not created any solid object, therefore what happens is that there's nothing meshed here. You have to do that yourself. Anything that's bothering you, you can actually hide it. So that sketch I can hide, that sketch I can hide, etc. Now I'm going to use a triangular element right there. See that on that surface? Yeah, parabolic, that's okay. So this size, if you want to look at the mesh, you put the cursor there, right click mesh visualization. There we are. You can make it smaller, you can make it bigger, whatever you wish. Right click deactivate. Now, let's give it a thickness. So 2D property, there's the 2D property, model manager, where the traffic light is, 2D property. You select it, and whatever surface whatever thickness you put in there, it's going to take it for the entire thing. If these were not talking to each other and you did not join them, then you can individually specify surfaces, uh, surface thicknesses. So this is, I think it says 2 millimeters, right? 2 millimeters, right? Good. We're pretty much done here. This bottom is clamped. Now notice that these three edges are in the plane of symmetry, in the YZ plane of symmetry. So this edge and that edge and that edge is in the YZ plane of symmetry. YZ plane of symmetry means that there is no translation in X and rotation is exactly the opposite. Good. And the other edge, let's uncheck all of these so that we don't inadvertently make a mistake. This edge lies in the exit plane of symmetry, so no displacement in y. Rotation is exactly opposite. So this takes care of symmetry, but I also want to take that circular edge and push it down by some amount. Remember, in Catia, if you want to push this thing down by some, or you want to push it by some amount, first you have to give that amount to be 0, and then you can change it. So in this case, I'm going to use user-defined. user defined. This edge, this circular edge, I want to push it down means the Z direction. So first I have to make it 0. And once you make it 0, you can go change it. This is the last restraint, yeah. In predefined, what is that? The enforced displacement. Under the load section, enforced displacement, you select that last restraint and you want to push it down by -2 or -1 millimeter. -1 millimeter. Okay, that takes care of it. Let's save the analysis, file, save management, analysis, save as in that same folder, which was called homework 5 problem 1. And then we're going to run it and let's see what happens. Okay, deflection looks like that. This is what I expect. Yeah. If you want to see, for example, one Mises stress, you do it and then you change the rendering to material shading. This tells you that the mesh is not very good here. Obviously, look at the patchiness here. This is a terrible mesh, obviously. Now I'll leave it like that because we're not going to do mesh conversions. In the absence of mesh conversion study, none of these numbers can be trusted. These things are totally useless. You have to do a mesh conversion study, make sure that this whole thing makes sense. Now, if you want to know how much force is needed to push down, put the cursor on sensor, right click, you go down here, reaction sensor, and you select that restraint that you use to push it down and update. Now notice that you could have also selected these clamp, the bottom clamp, because the force needed to push this thing down is essentially the force needed on the clamp because they balance each other out. Now, the number that you have to write, if you were asked to give me the force needed to push that circle down, the entire circle down, is 4 times that, roughly 160, almost 162 pound force. And of course, you can convert your units to newtons, etc. So don't forget to multiply this thing by 4 if you want to know how much force is needed to push this thing down. And that takes care of this homework. Let me save this thing and stop that.